Welcome to the hardness testing experiment, where we shall be doing the Vickers hardness test and the Show A hardness test. The Vickers hardness test is performed on metal specimens to measure its Vickers hardness value. A small indenter with a diamond tip presses onto the surface of the material, and the measured dimensions of the impression on the surface are used to determine the Vickers hardness value. We shall be testing using the micro hardness machine, which consists of a viewfinder with a lens and two knobs by the sides, and also a red button which we shall use to record our values. This setup also has a 40 times objective lens, a diamond tip indenter, and a 10 times objective lens. The testing stage could be raised towards and lowered away from the lenses using the two knobs by the sides of the machine, and could also be moved laterally in both directions using the screw gauges just below the stage. There is also a display screen from where we could take values of our readings, and also buttons from which we could make settings for the experiment. On this experiment, we shall be working with aluminum, copper, and steel specimens. To begin this hardness test, we turn on the machine using the switch at the back. The machine will boot and the control screen will be displayed. 0 indicates that we're now ready to calibrate this machine. Turning the left knob moves both parallel lines at the same time, whereas turning the right knob moves the right line relative to the left line. A calibrated system would show that both lines have been merged together to become one line, and when this is done, we could hit the right tick button on the control screen. Next, we will need to set up the test conditions. To do this, we would move over to the force settings and select a force of 0.2 kilogram force. Now the system indicates that we're working with a 10 times objective lens. We would need to change that to the 40 times objective lens. Once we have set the testing conditions, we can now place the sample underneath the lens and adjust the stage. We should adjust the stage until the surface of the specimen comes into focus. An out of focus specimen looks like this, whereas an in focus specimen looks like this, such that you could see some properties of the surface through the lens. Once it is certain that the specimen is in focus, we can now hit the run button and the machine switches from the lens to the diamond tip probe. The diamond tip probe will now press upon the specimen and there will be an indentation dwell time of about 10 seconds, after which it switches back from the indenter to the 40 times objective lens. To view the indentation, you would need to look through the viewfinder. What you should see now is the surface of the material with an indentation mark. To take our measurements, you would need to adjust the left-hand knob whilst looking through the viewfinder, and this would adjust the pair of the parallel lines over the specimen. You will need to set the left line to the left edge of the indentation and adjust the right knob until the right line is aligned to the right edge. When completed, touch the red button to take the readings and flip the viewport through a 90-degree angle, and repeat the same process, this time starting from the bottom line and using the top knob to align the top line. When this is done, you could bring back the viewfinder to its original position and press the red button to collect the dimension and the hardness value. This same process can now be repeated for the steel and for the copper specimen. Once this is done, we unload and lower the stage, and then turn off the machine by flipping the switch at the back. The Show A hardness test is performed on polymers with low elastic moduli. The durometer displays the Show hardness values with a value of 0 indicating no resistance to deformation and 100 indicating extreme resistance to deformation. On this experiment, our setup shall be mounted on a test stand. The test stand consists of a show A durometer with a display screen, a needle at the bottom, and 3 buttons. The hold button keeps the value on the display, and the 0 button is used for calibration. A testing stage is situated at the bottom of the test stand, a lever that applies the load on the specimen, and a screw that maintains the position of the crosshead. We shall be testing with cold silicone, PDMS with 30% volume of iron powder, rubber, and PDMS. To begin the experiment, we adjust the crosshead to a height that is suitable for our material thickness. Next, we place the specimen on the stage and the lever is pushed downwards so that the weighted gauge rests on the specimen. We press the hold button and take our readings from the display. This same process is repeated for the different specimens, each time using the lever to press the protruding needle onto the surface of the specimen and reading the values on the display. Good practice requires that values close to 0 and 100 should be met with caution, as the show A hardness test may not be sufficient for such materials. When testing is completed, we unscrew the durometer from the testing stand, remove the battery, and store away in a different compartment.